All right, what's up, Integrated Math 1? It's Coach Osborne doing your Chapter 6 review. I'm going to go through this, and this will be an Edpuzzle format, so answer the questions as we go. Feel free to come by if you need help. All right, start with number 1. Okay, when you look at these problems, please look at what it's asking you to do. Solve for y. Solve for x. Solve for x one more time. So that is the variable that we need to isolate, get by itself on one side of the equal sign. So here's solve for y. I need to get that one by itself. Solve for x, I'm getting that by itself. And then here, solve for x, I'm getting that by itself. All right? So looking at the first one, I want to get that by itself, so that means it's locked. I don't want to move it. I'm not going to move that 6. I'm going to move the other number that's on that side. So I'm going to make my line stay organized. It's a positive 2, so I'm going to subtract that 2x from this side. Also from this side. Now remember that negative 6 and the negative 2 are not like terms, so I will not add them together. That goes away. I have negative 6y equals, I like to put my x before any other numbers, minus 6. But then again, that y is not by itself. It has a y right next to it. Okay? So to get rid of that 6, we have to divide it all the way across, every number. Now do this very carefully. Negative 6 divided by 6, that's the same number, so it is a 1. So that just kind of goes away. Okay, so we just have y. Hey, look, y is by itself, so whatever I have left is my equation. So negative 6 over, negative 2 over negative 6. Well, it's a negative over a positive. Okay, so these both become positive. And then also I want to reduce this. This is a smaller number over a bigger number. Okay, so we're going to reduce it by dividing both of those by 2. Divide by 2, I get 1. Divide by 2, I get 3. And then I also still have an x here. Here I got negative 6 divided by negative 6. That's a positive 1. Okay, and I could probably do a better job of drawing my x, but as long as it's right next to it, we're good. Hey, look, I got a new equation. Not like a solution, but a new equation. Okay, so you're not always going to get a solution when you solve for a certain variable. Okay, now we want to get x by itself, not the y. So that means that now the 6y needs to move. It's a negative, so I'm going to add it to both sides. Same rule applies. Those are not like terms because they are, one has a y and one does not. So I have 2x equals, I always like to put my variables first, so I'll put the 6y first, and then minus 6, and then same thing over here. Except this time I want to get rid of that 2, because again the number next to the variable, that becomes 1 again. Now I just have x. 6 divided by 3, now it's a bigger number on the top, so I can divide that, and it goes into evenly 3 times, and it's going to be 3y. And then negative 6 divided by positive 2 would be minus 3. There's my new equation. Okay, we just solved for y and x. Now, I don't have any numbers. I've got like 4 different variables. 1, 2, 3, 4. Okay, you're still going to do it the same way. I want to get x by itself. All right, so again, I'm going to draw my line. So again, I've got this m and this x next to each other. It's almost like the 2x over here or the 6y over here. So I can't just subtract m from that side. I have to divide out that m. But in order to divide, I want to take away all the other factors or numbers or terms first. So I'm going to take away this b, just like I took away the 6y here, or the negative 2x, the first step here. So I take away b from here. Obviously, y and b are not the same. So on this side, I'll write y minus b equals m times x. Now the same way that I got rid of the 2 and then that I got rid of the negative 6, I'm going to divide out the m. Divide m here, that becomes 1, so just x. Divide m here and divide m here. Now usually if it's just a number, like 6 divided by 2, I can combine those, make a fraction, make a number, but here I can't divide 2 different variables. So I literally am just going to leave it like that. Now I can write this 2 different ways. Y over m minus b over m. But if you notice, they have the same denominator. So when I divide, I could just divide the whole thing by 1m. So the other way to write this is y minus b over m. equals x, because this is the same as that. Okay? All right, so now down here, we're going to graph each of these equations. That's what it means by graph each line, because that's a line and that's a line in the system below, and state the point of intersection, which is the solution where they cross. Okay, so first I'm going to start with this one. Remember that your starting point is -1, so I'm going to find the -1 on the graph. Okay, then I'm going to follow the slope, which is the -2, or the same thing as -2 over 1. Okay, so which means I go down 2 and then write 1, down 2, write 1. And remember, I'm going to write out as many points as I can. So I want to go back up this way as well. So I'm going to go up 2 and this time left to continue the pattern. Up 2 and left, up 2 left, up 2 left as far as I can go. Okay, I'm going to grab a ruler, make a nice straight line. Actually, before I make the straight line, let's do the points for the other line, just so we can find the solution first. Okay, so we start at 5 for this one, which is right there. And now here, the slope is 1, or the same thing as 1 over 1. So we go up 1, right 1, up 1, right 1, like this. Okay, and obviously the solution is going to be down this way because that's where the lines meet. So I go down 1, left 1, down 1, left 1, there's my solution. Okay, but I'm just going to go ahead and continue my points, as many as I can. All right, now I'll draw my lines to complete the graph. Don't just leave your incomplete graph with just dots. Complete the lines and make sure you put arrows on the end so we know it's continuous, meaning that it goes forever in both directions. Okay, there you go. And now that point of intersection is your solution, which you need to put here. So it's over -2 and then up 3. There's your solution. Okay. All right. Now solve this system of equations using any method you want. Okay. So remember we have elimination. I'm only going to write this once because we'll do it again. Substitution. Equal values. Okay. Those are the methods that we've been looking at. Okay. So in this case, I see that the variables are lined up. I've got x over x. And I've got y over y, and I also have numbers over numbers. Okay, so that indicates to me probably elimination would be a good choice here. Now, if I add these together, this does not cancel because these aren't the same and these aren't the same. So what I do is I'm gonna first I got to pick a variable to eliminate. So I'll pick x to eliminate, and I've got to multiply to make them the same. Okay, so this one I'll multiply times 4, and this one I'll multiply times 3. Okay, because that will make this 12, and that will make this 12. Okay, in other words, I'm taking this number, multiplying it here, and taking this number, multiplying it there. So if I wanted to eliminate y, I could put the 2 here and the 6 here, or I could just multiply 2 times 3 to make it 6. Now I could just multiply one equation. Okay, either way works. You'll get the same answer. Multiply everything. So here's my new equations. The first one, 12x plus 8y equals 8. Remember, you're multiplying every number, including that one. Then the next one, 12x plus 18y equals 3 times 16. That is 48. All right. So now I've got a 12x and a 12x. In order to cancel those, I need to subtract them. So this whole side I'm going to subtract. So that means on this side I also have to subtract. So that means this will go. Okay, so now I'm going to do 8 minus 48, which is -48. I actually redid this because I made a mistake here. I did 8 minus 48 a minute ago and put 10 instead of 40. So I am redoing this. In case you saw a little lapse in the video. Okay, so now I divide by -10, and -4 divided by -10 is +4. So now I'm going to take that 4 and plug it back into one of the equations, and it doesn't matter which one. And remember, you're looking for x, so because we already found y, so that's why we're going to plug it into where you see 2y. So pretty much right there. Okay, so now let's just simplify and solve. Okay, so 3x plus 2 times 4 is 8. Okay, then subtract 8 both sides. and you get 3x equals -6. Okay, and then divide by 3, x equals -2. Now the funny thing is I actually made a mistake a minute ago, and the way I found my mistake was that I checked my solution. And yes, this is required. If you see check your solution, you need to check it. Okay, I did this equation, it worked, and I went over here and it didn't work, and I was like, oh wait, I made a mistake. So that's actually redid the video. So even teachers make mistakes, but we check our work too. So I plug in the x and the y here, so I get -6 plus 2 times 4 is 8. -6 plus 8 is 2, so that works. And I'll do the same thing here, -2 and 4, because remember I'm plugging x in here, and then y here. Okay, so then -2 times 2 is -4. 6 times 4 is 24. Oh, I just realized too that this is written incorrectly. This should be a 4 for the second equation. I was like, wait a minute, it's still not working again. Okay, so it's actually a 4 times -2. So change that, edit that. Okay, and then -8 plus 24 is 16. So that does work. Whew, almost thought I made another mistake. Okay, so now let's go down here to the bottom. Move down here a little bit, zoom out so you all can see it. All right, last part of this first page. Okay, the fabulous footballers. So you notice there's a word problem. So we're going to probably have to find some equations, which we gave you. So you have to pick what the right one. The famous footballers scored 38 points. Well, I'm just going to take a guess. That's probably a total, because if you scored, that means at the end of the game you scored. And I'm already seeing 38 in the equations down here. So just as you read, kind of look at the equations and kind of start guessing where you think it might be. Okay, interestingly, the number of touchdowns, was 2 more than 3 times the number of field goals. So if I multiply the number of field goals times 3 and then add 2, that's equal to the number of touchdowns. Okay, so 3 times the number of field goals. All right, so that's an important piece of information. So obviously, part of the equations can be created from that statement. The fabulous footballers earned 7 points. There's another earned, meaning some kind of total. Okay, earned 7 points for each touchdown. Okay, actually, you know what? That's earned 7 points just for the touchdowns. So that's the first part. And then 3 points for each field goal. All right, so 3 points for each field goal. All right, so that means every touchdown they got 7 points. Every field goal they got 3 points. Which system of equations best represents this situation? Let's first think about variables. So obviously they're using T and F, and T for touchdowns and F for field goals. Okay, so that's actually right here. Create let statements. That just means T equals touchdowns. So that's where we want to put our variable representation. So F is equal to field goals. So basically, it doesn't really ask the question, but basically it's asking for how many touchdowns did they score and how many field goals did they score. Okay, so now remember, we know that the score is equal to 38 points. So let's look at the first equation and figure out what that is. The number of touchdowns was 2 more than 3 times the number of field goals. So if I multiply the number of field goals times F, or 3 times F, okay, and then add 2, that should equal the amount of touchdowns. So let's look for that equation here. So I see it here. I see it here. It's just the T's on the other side. But I don't see it here because this is 3 times 3. 3 times T, not F. So that's not it. That's not it. So it's one of these two. Okay, now remember that you earn 7 points for each touchdown. So every 7 points, if I multiply 7 times the amount of touchdowns, so it should give you total touchdown points. And then 3 points for each field goal. So 3 times every field goal gives us the total field goal points. That should equal the total points scored. 38. So that would be 7T would be this one. So A. Okay, so that means we got to solve that system now. Now we got to decide what method we want to use. Well, I noticed right away that this equation has one variable by itself on one side. So what I like to do is if I have a variable by itself, I'm going to take the other part of the equation, the other side of it, this part, and plug that in to where it's equal. So this whole thing equals t, so I'm going to plug it right into t, into the other equation. That's substitution, like what we talked about a minute ago. So first we did elimination for this one, and now I'm going to use substitution. Okay, so now I'm going to take, again, this equation, plug it into t, because it equals t. So I'm going to plug that in there. Plus 3f equals 38. All right, now let's solve, simplify and solve. 7 times 3f, 21f. 7 times 2, 14. Plus 3f. Okay, so here I've got some like terms. That's not a like term. Well, it's not like this one, but it's like that one. So let's combine those. So 24f. Now plus 14. Now these two are like terms, so let's get that one on this side. So subtract the 14 because it's positive. And sorry, hopefully I'm not confusing you. I'm not dividing here. This is not division. Okay, I was just writing a line to show that they're like terms. Okay, so now 24, oops. So let's write an f. 24f is equal to 38 minus 14, which is 24. So divide by 24, and that equals 1. So the amount of field goals was 1. We just had one field goal. But now we got to find the amount of touchdowns. So I'm going to take that equation, the easy one, and plug it in there. So f goes here, because it was 3f. Okay, plus 2 is equal to t. So 3 times 1 is 3, plus 2 is going to be 5. So the amount of touchdowns is 5. But don't just leave it like that. This is actual situation, so let's write out a sentence. And actually, before we do that, let's actually check our solution. Okay, so I'm going to plug it into the first equation. So f was 1. Okay, plus 2 is equal to 5. Okay, so 3 times 1 is 3, plus 2 is 5, so that's good. And then the first one, the next one, 7 times 5 touchdowns, 3 times 1 field goal. 7 times 5 is 35. 3 times 1 is 3. 35 plus 3 is 38. So that's good. All right, so now let's write a sentence. So I'm going to write check here because I checked my work. Okay, so they scored 5 touchdowns and 1 field goal. Okay. All right, that's the first page. Watch the next video for page 2.